Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will continue our project to look at the use of software autoforms. This was our application at the end of the last video. We have prepared a generic application whose dialog contents are driven from a metadata configuration file. This configuration file designates which objects appear where on the screen, and we have added additional columns to center titles, specify which button is the save button and which is the exit button from the application. We've also set additional properties for our drop-down list and our list box to do sorting. The field name column is used to specify the file which is created when the user hits the OK button. It also holds the names of the columns we wish to save to that file. What we're going to do today is we're going to add the ability to have fields which are mandatory, fields which the user must fill in before it will allow the form to be saved. Additionally, we're going to add another text field, and this text field we're going to set to accept numbers only. So let's have a look at the code to see how we're going to do all of this. So as we're going to add new columns to our configuration file, we're going to expand our enumeration at the beginning of the application. We're going to add two new columns, one to designate a field which is mandatory, and a second field to designate the maximum number of characters that will be accepted on a text field. And we're going to add these two new fields to our configuration file, the testdemo.csv file. And there are our new columns in place, a mandatory column and a character limit column. We have also added a new label and a new text field to the configuration file. We'll cover these as we get to them in the code. So if we run the application now, we will see our new field, the age field, is appearing on the screen, just as the text fields we did in the last video. So let's see what changes we now have to make to the bulk of the code. So let's first look at the populate form function. This is the function that creates all the objects on the dialog. We're going to create a local variable here to hold the value that is the character limit, the maximum number of characters that's going to appear in a text box. And I'm also going to make use of the long control variable which we created in the last video but didn't populate. This is picking up the reference ID from our configuration file. This is the Windows handle to the control on the dialog. This variable will make the rest of the code a little easier to read. We can replace this line of text with that single variable. And we can do the same all the way through the rest of this function. We need to add some more coding to support the new functionality for our text box. This particular age text box is to accept only numbers from the keyboard. So we will need to conditionally test to see whether the function of this particular object is set for number only or not. We can do that with a simple if statement using the parse command. So if the value in the function column is number only, then we can execute the next line of code. We already have two variables set up for the style and the extended style of objects, so we can populate those quite happily. So we will first of all set the default value for both the long style and long x style variables. These are the values a normal text box will have. And should our text box have the number only setting set, we will add an additional property. We will add the ES number property. This will instruct the dialog control to only accept numbers. We merely have to add these two additional parameters to the end of the control add text box command. So let's try that code and see how it looks now. If we get into the age field and attempt to press a number, it will take the number quite happily. If we attempt to press the letter keys, it will not accept the input. So we've now achieved the ability to have a text box which only accepts numbers. So how do we limit it for the number of characters? It's unlikely we would have someone working for the organisation which has an age over 100 years old. So a 3-character limit would seem quite reasonable for this particular field. So having created the text box, we now have to test to see whether the char limit is set or not. So we're now populating the long char limit variable. This is picking up the value that's in our char limit column. As we can see from our config file for this particular text box, we set a character limit of 3 characters. So the value pushed into this variable will be 3. We can now easily test to see whether the value in the variable is greater than 0 or not. If the value is greater than 0, we can put in a new command. This is a control post command. This sends a message to the dialog and the control on the dialog, in this case to set the text limit, the number of characters that the object will be willing to accept. And we're passing in the first parameter as being a 3, the value within the char limit variable. If we try running the application now, and go into the age column, we can put 3 characters in quite happily, but as soon as we try to add the 4th, it will stop us adding any extra characters. So we've now limited this number only field to hold only 3 characters. So our next task is to look at making some of the fields mandatory. If we look at our configuration file again, we can see the mandatory column. And I've set 2 of the fields, the name field and the department field, to be mandatory. In other words, it will not allow you to attempt to save the form without those fields being populated. So let's see how we can do that in the code. So in order to do validation on the form, we need to look at where the form is actually saved. And this is in the run control process function. This is a function that's acting as an event handler for the form. If we scroll down in here, we'll see where the save is actually triggered. When the user clicks on the OK button, this is where the save is actually carried out by calling the save form data function. We now need to make the call to this function conditional. Prior to saving it, we need to call a new function which we'll call validate form. So we're going to pass 2 new variables to this function, an error variable and a field variable. So we will declare them at the beginning of this function. So before we create this new validate form function, let's look at the logic in the code that should be triggered when the validate form function returns false to say that the form has not validated. If it's failed validation, then we will get a value put into the error variable. And we want to display this on our status bar at the bottom of the form. This will allow the user to see what the error actually is. Additionally, if one of the fields has failed, we want to set focus to that field to allow the user to quite easily go in and amend it. So as we've done before, we're going to use the control set focus command with the 2 parameters of the handle for the dialog and the handle for the field which is an error. And at that point we can exit the function. So now that we're handling errors, we can now create the new validate form function with its 2 parameters. So here is the skeleton for our new function. There are 2 parameters, both of which are output parameters. These are values which will be passed back to the calling function to provide it with the information that we need to pass on to the user. We've created a number of local variables. A loop counter to keep track of each of the objects that we're looking at, the column number of the ID column, the type of object we're looking at, be it a text box or a button, the column number of the object column, the str data, which is going to be the data we're pulling back from the object on screen, the mandatory column number, and the handle of the control on the dialog. We also have the name of the field, which in this case is the one that may have failed validation. So we're going to populate some of those column numbers now to get the column number out of the configuration file. So we're interested in three: the object column, the ID column, and the mandatory column. As we did in the previous videos, we're using the parseFind function, which is in one of our libraries. This is to pull back the column number that each of these particular titles is actually held in. The column number of the object column, the ID column, and the mandatory column. And next we're going to do a for next loop to loop through each of the records in our configuration array, which has come from the configuration file. This will look familiar to one of the functions we've written in the previous video. The for next loop is first of all going to pick up the data in the object column, and then we're going to blank out the str data variable ready to be populated by what comes off the screen object. As we only have three objects on screen that would contain any information, the text, the list box, and the drop-down list, we can test on those conditionally. If it's not one of these, then we don't need to do anything. So we're populating the control number by picking up the value in our config file from the ID column. We next have to test to see if the mandatory column has a yes in it or not. If it has a yes, then we want to check the value held within that object on the dialog. And as we did in the previous video, we are conditionally checking the type of object as we use a control get text to get information out of a text box or a drop-down list. And for a list box, we're using the listbox get text command. Both of these commands will populate the str data variable. If we get this far, then the object we're testing has been deemed to be mandatory. We can now test the value populated into the str data variable to see if it's an empty len string or not. If it is an empty len string, then we know the function is going to return false, because validation will have failed. So in order to inform the user as to which field has actually failed, we're pulling back from the configuration file the value in the field name column. So this would either be the name field, the address field, the department field, or the skill field. And as only two of these are set as being mandatory, it's either going to return name or department, as these are the mandatory fields. So all we need to do now is to populate the two variables we're passing back to the calling routine. First of all, the control handle of the object, and the text we want to put into the status box at the bottom of the user's screen. So having passed back the information for validations which has failed, the last thing we need to do in the function is return true. So having populated the variables, which will go back to the calling routine, we now have to exit the function, as the validation for this particular form has failed. And our final act in this function is to return true if all the validation has been successful. So if we run our application now, we should get the form on screen. If we just hit the OK button, it will tell us that one of the mandatory fields is actually empty, the name field, and it has set focus successfully to that field. If we enter in the name and then attempt to hit OK, it would tell us that we have not yet picked the department, which is the second mandatory field. If we pick that and hit OK, the form will be saved. All the other fields which we left blank are not mandatory fields in this particular scenario. So if we have a look inside our code folder and inside the data folder, we'll see that the user data CSV, the output file, has been successfully populated. And there is our new entry for Tom Jones, with the name and the department being populated. We left the other two fields completely blank. We are not yet outputting the age field, so let's have a look at the code to see how we can set up that additional field to come out on our CSV file. So our issue at the moment is we don't have an extra column for the age field which we want to output to the file. If we have a look in the saveform data function, we can see there's a test within this function to see if the code exists or not. And in there, we're appending to the file to put out the headers. So as the file already exists, we're not recreating the headers of the file. So one solution to that problem is to delete the output file and let the program recreate it. So adding a new column would mean you would have to erase the text file that exists already. So let's try that logic and see if it works. We've now erased the file, and if we try running our application now, and we'll put some data in. So let's look to see what's appeared in the file. And there we have the age column. So if we're going to dynamically add new columns while these files are in use, we would need to actually put some additional code inside the application to cater for that. However, we may leave that for a later video. So in summary, what we've done today is we've created two new columns in our configuration file. A mandatory column to designate which of the text fields are actually mandatory or not, and a character limitation column to limit how many characters are the maximum that can be put into a text field. Additionally, we've added to the function column to allow text fields to contain only numbers. And to ensure the mandatory fields are actually filled in, we've created a new function which can be used for validation. So any form which fails its validation will not be saved to the file, but rejected and sent back to the user, indicating which field is an error and setting the focus to that field to allow the user to enter it. Hopefully you'll find this code useful, but that's it for today. Thank you for watching.